I know this is a really tough time slot to be in. We just had this great lunch and you're probably a little sleepy, so if I see people nodding off, we'll just open the windows and do some exercises to wake you back up. No, just kidding, won't do that to you. I'm here today to speak about JSON API and why I think it's the ultimate anti-bike shedding weapon. And just to be clear, I am speaking about JSON API, the specification, and not just APIs that use JSON as their content type. So a little bit about me, that's what I look like on the internet. My name is Henning Glatter-Götz, and I am a backend developer, at least that's what I would categorize myself as. I've done a substantial amount of work integrating with APIs, developing them, and also just consuming them. And in the last 2 years, I would say, I have been dabbling a little bit in Ember.js. It's a JavaScript front-end framework, so I can build simple UIs for my back-end systems, mainly just for myself. And that's actually how I got to know JSON API. And how those two relate to each other, we'll get to that. So in my spare time, I like to podcast. I am the co-host of a show called Reactive, which is a weekly panel discussion, goes about an hour, that I host with Khalil Lechelt, who is here today. And actually he was going to be here with me on stage tomorrow speaking about JavaScript front-end frameworks. So if you're interested in that, come and check that out. And another host on the show is Raquel Velez, and she is with NPM. We just basically talk about the news of the week in the tech industry with a focus on JavaScript. And because one podcast is not enough, I co-host the second one, also with Khalil Lechelt. This one is called Descriptive, and what we do here is we talk to people in our industry that we are interested in or that our guests suggest, and we discover their programmer origin stories, basically meaning that we ask them how they started to get into programming and how their career progressed until the present day. And there's some really, really interesting things we've heard. We've spoken to people like Jafar Hussain, which you might know from Netflix. He's the architect of Falcor. People like Steve Klabnik, who is actually the co-author of JSON API, and many others. We have 24 episodes now. So check that out if you're interested in that. This is the official logo of JSON API. And as you will notice, if you do anything with JSON, this is actually not valid JSON. But I promise you this is not a reflection of the quality of the project. These people actually do know what they're doing, and they do know how JSON is supposed to be formatted correctly. Their argument, I guess, was that it looks cooler than that. So I guess that's true. So I'm going to talk about APIs that go over HTTP and have JSON in some form as their content type today. So if those two things we consider as common, and the question then becomes, what do most of these APIs actually have in common? And if you've consumed or built any significant number of APIs, you will unfortunately probably come to the conclusion that the answer is this. It's not very much. What I mean by that is that most APIs, or not some APIs, deal with HTTP response codes in different ways. They have different query parameters for the same kind of thing. They might represent relationships differently or not at all. So what that means is that you, on top of learning the domain knowledge when you encounter a new API and learning about what it actually is that it does for you, you also have to learn all the nitty-gritty little technical details and how it works so you can make it, so you can consume it basically. And what this also means is that you're writing custom code every time you encounter a new API. So you're writing custom clients to consume APIs. At least that's been my experience over the last 6 or 7 years. And I've integrated with quite a few APIs at this point, also some big reputable companies. And the interesting thing there is that even with these companies where you think they have their stuff together, they have differences between endpoints within the same product. And that's extremely annoying. I mean, things like just how, when a query is performed, How is a collection represented that has multiple results versus a collection that is either empty or has only one result? If you've done this kind of stuff, you probably know what I mean. And the other thing that, one of my favorite ones is for example, APIs that return error code or response code 200 for absolutely everything, even if an error occurs. And what they will then give you is a custom error document inside of the 200 response that you then have to write code for in order to parse. And then they probably have their own custom error codes in them that mean something very specific. So you have to write this huge library to consume this API, which, again, you have to do things over and over again. So to put this another way, I'd like to use an analogy that Steve Klabnik, that I heard from him. And he's, as I said, one of the co-authors for this standard. So basically, we are here in Austria, where the language is German. But we are here in Topconf, the conference, where the organizers have wisely decided that we should speak English because that is probably the common language, or the most common language, where all of us can understand each other, because we have people here from 10 different countries at the moment, I think. And it would be absurd to think that I would stand up here and I give the talk in English for the English speakers, then the German speakers come in and I give it in German, and that's pretty much where my abilities would end, because if then I had to do the same thing for the Italians, I'd have to go and study Italian to learn that, come in here, give the talk in Italian, the same thing for Polish and whatever other languages there are. So we would, I think, all agree that that is nuts, right? It doesn't scale. But unfortunately, that is kind of what we're doing in API land. Granted, it's not as extreme. You don't spend months or years learning the language, but it is time that you have to invest in order to get to know the technical specificities of each API. So you're learning stuff over and over again. And I do realize that you can't, go out to Google and say, hey, I just learned about JSON API, go and change your standard. I want all your APIs to be in JSON API now, so I don't have to learn that anymore. I know that's unrealistic, but at least you could apply this or something similar to your own APIs. And if you're an agency, for example, and you're doing back-end work for each client over and over, you could very easily apply something like this and make your life a lot easier. But you might say, well, we have our own thing. I don't need a standard. And if you have spent years and you've arrived at something that works really well for you, congratulations. But chances are you're not there yet. And another thing is that you might not even have started doing that. So the other thing is that you probably don't, what you're going to encounter is basically when you have a team trying to build something, you're going to have arguments or discussions about trivial little things. For example, do we represent our resource names singular or plural? What do we use for our sparse field set parameter name? Should it be fields, columns, whatever? And so you argue about these little nitty-gritty little things that just burn up a bunch of time and are not really essential. So in other words, you're spending a lot of mental energy on the small stuff, right? And there's a word for this, and it's called bike shedding. And that's just another word for Parkinson's law of triviality. And put in different words is, if you have a team of engineers that are supposed to design a bike shed, they will spend a disproportionate amount of time and passion arguing about the color that the bike shed should be painted, rather than designing the actual bike shed. And I think that happens quite a lot with developers, and at least that has happened to me. So basically, when you have a team that has to decide certain things, usually you get emotionally attached to your ideas, and you might not let them go that easily. And if you all don't, then you're much better people than I am. But when you bring an outside standard in that everybody basically can agree on, and everyone has to sort of give up or compromise to the same degree, it is maybe more likely that you will accept that and use that standard instead of trying to come up with your own. And besides, this has been going on for 3 years. They've been working on this for 3 years, and it's in 1.0. It went 1.0 last year, so it's guaranteed to be stable. It's guaranteed to be backwards compatible, just like the web itself. And that's why I think it's a very good option to adopt to basically develop your own APIs. And JSON API is not the first attempt to do this. There's others, such as HAL, it's the hypertext application language, Siren, OData, and there's a few more. But JSON API is particularly well suited for single page applications. Not only that, but really particularly single page applications, because it was actually extracted from Ember data itself, which is the data layer for Ember.js. That's where those two things come in. Yehuda Katz basically took that out of the Ember data library that they had back then and came up with the first draft of the standard. And since then, people like Steve Klabnik and Dan Gebhardt have taken this into version 1. And they're actually working on version 1.1 right now. So that was sort of the history behind it a little bit, the theory. Let's talk about some specific stuff. I'm just going to let you know what's covered by the standard itself, which is content negotiation. The document structure, I'll go over that in very rough terms. How we fetch data, creating and updating data, as well as deleting resources. Query parameters, there are some reserved ones. How errors are represented, and one of the things that's really important to me is HTTP status codes. It actually dictates how and in what cases which kind of status is supposed to be used, which I personally think is very nice. So content negotiation, if you've dealt with any kind of API with JSON, you're probably familiar with content type equals application dash or slash JSON. This standard has its own registered content type, which is application slash VND.API plus JSON. So just in case it's not important, just in case you encounter it, you're wondering what the heck that is. VND stands for vendor, but this is the one for JSON API. The document structure itself, like I said, we'll do in very, very basic terms. So let's assume we have two models, articles and people, as very, very simple ones. The articles has ID, title, a body, and a created date, and the people or a person has ID, first name, and last name. And the simplest thing I could think of to request a single resource, in this case an article with ID 1. This is the bare bones document that would be still valid and would be in the response. So essentially it has a top level key called data, always, unless there's an error. It always has the top level key data. And inside of that is either a collection or a single resource. In this case, because we requested one, it's a single resource. And a resource has at minimum type, ID, and attributes. And those are also reserved words, so you can't have type or ID inside of the attributes. I think the same goes for attributes too. And then attributes is, so type is simply the type of the resource, so the serializers and deserializers know what they're dealing with. ID obviously is just the unique identifier for the resource. And attributes is simply an enumeration of all the fields. But we said that we have two objects in our example, and they're actually related to each other. I decided that an article has exactly one author. So the relationship would be expressed like this. Basically, there's a relationship key underneath attributes, and inside of it are named relationships. In this case, we have author, and it has links to itself. So the resource, the relationship resource has a link to itself. If you wanted to fetch that, you can do that with the first URL. And related is actually the URL to go and get the author for this particular article. So this is how the server communicates to the client, hey, if you want to go and get these other things, here's the links for that. Go ahead and do that if you so choose to. But if we want to actually not do a second round trip to the server and we want everything at once, we can also do that with a reserved query parameter called include, and we just basically specify which relationships are supposed to be included in the response. And in this case, we say include the author. So the whole document looks the same, except for inside the relationship, we have now a data key, which looks a lot like the top level, and it has one resource identifier object in it. It's not actually a resource because it's only got the ID and the type. Essentially, this is a pointer. It's pointing to somewhere else in the document. And in this case, I omitted the content of included just because it would get too small to read. So I put it in the next slide. Everything that we saw before is now basically gone or replaced by those two dots. And included would look like this. Exactly the same as the top level. You would have a resource in here that represents the person with ID 9. It has a first name and a last name. Now if this person had a relationship to, let's say, a profile, then you would have the same kind of relationships key with the links in it. And if you say you wanted to include not only the author, but also the author and its profile, you would then say include equals author, comma, author dot profile. Then they would both be included, and it would simply be included in at the same level as the people resource here. So you can recognize that there's really only one level deep. The whole document is always only one level deep. There is no nesting, right? And one of the benefits to that is document size. So if you think about it, if you want to do a query and say, give me the first, I don't know, 50 articles that were written this year. If, let's say, half of those are written by the same author, you can see if you did something like HAL, where you have the relationships nested, where you'd have article and you'd have the author inside the article, and inside the author you would have the profile, you would get this enormous document with a ton of data duplication. And this way you can shrink your payload size. So those are some of the simplest structural things I wanted to show you. The specification also handles things like what characters are allowed in query parameters or keys or names, how meta information is communicated. So for example, if you did a query, again, give me all documents written last month or something like that, but only give me 50 for now, and the result actually had 256 or whatever, then in the meta key you could say the complete result contains this many 256 results. So information that's not directly related to the data could be put in a meta key. The spec also talks about how to deal with pagination and filtering. So one more interesting thing in the URL, or how sparse field sets are handled. This is also a reserved word. It's called fields, and you can basically think of it as if you had some sort of resource that has a really large number of fields, you can specify exactly which fields that you want out of that. In this particular case, or this example, I say fields for articles, for the resource articles, only give me title and the date. Now if you wanted to limit the response for the author as well, you would simply have another fields parameter with author in the square brackets and then a list of whatever fields that you want for that. Sorting, also a reserved thing, just the word sort. Ascending, very simple, you just put a list of fields that you want to have it sorted by. Descending, you put a minus sign in front of it. Again, if you have multiple fields, it's just comma separated. All right, and errors. This is very, very lenient or lax, however you want to call it. The only requirement here is that you have a top-level key called errors. And inside of it, or errors then basically is a collection of objects, whatever you want it to be. They do, however, have recommendations. The recommendation is that it looks something like this, so it has a status with the HTTP status code. A source, in this particular case, it's just a JSON pointer that points to the place in the document that caused the problem, and in this case it's something I made up. It's the first name contained less than 3 letters. So that's how errors are displayed. Now, how does this help us? In a single word, it's tooling. Because when you have a standard that everybody or people can agree on, you can now start to build tools around it. And why do we want tools? Well, you can that way ensure repeatable results, right? And that's what we like. When we encounter something, we do something over and over and over again, we build either a script or a tool or something to do this. So in that case, that's what we could do here. And this allows us then to no longer have to focus on the technical part of an API. You can basically just say, okay, this API deals with articles or whatever it is, and deal with learning what that means instead of having to figure out how is it displayed, what kind of query parameters does it use, and so on and so on. So you no longer have to write custom client code, at least not as much. You have to write a little bit of descriptive code, but nothing that really deals with parsing the document or generating the document. And the other thing is, well, it allows the community, if we're talking about open source here, to come together and build tools for all the different languages that exist. And that's exactly what's happening. So for the client, there exists now several libraries for each of these languages. JavaScript, of course. iOS, I presume that means Objective-C and Swift. And Ruby, of course, PHP, and yes, Perl. I was quite surprised to see that. About 2 weeks ago, the company Booking.com released or open sourced their server and client library in Perl. And server side is a little more involved, but it basically contains all the server side languages of importance: PHP, Node, Ruby, Python, Go, .NET, Java, Elixir, and of course Perl. So I'm going to give you just a little bit of an example, so you have a sense, at least, of what it could be like to use something like this, and you can compare it to whatever you're doing today. Just because I know the Neomerx JSON API library, it's in PHP, I'm using that on the back end, and then we're going to use Ember Data on the front end, that's JavaScript. And just to be fair, Ember Data is probably the first JavaScript library to do this, and is probably the most advanced. And the amount of work required is ridiculously low, so it might not be that way for all of them, but we'll see. So essentially what happens is when you get an API request in on your server, you figure out what the query parameters are, you build your queries, and you go and have the database go fetch the data. If you use an ORM, you get back some kind of model object. In any case, you get some sort of model objects or object back. And in this case, the first parameter to this encoder instance is simply a map of models to schemas. So each article model, or the article model, has an associated schema that basically explains to the encoder how to interpret the various fields in the model into the JSON document. The same goes for author. Then if there were things like sparse field sets or included relationships, that goes into the encoding options. And then you basically just throw your collection of articles into the encoder, and out comes the JSON, and that's it. So this would be then the amount of work you do to create a GET request on the server side. The schema would look something like this. Like I said, it had to include the type so that it would know what the type of the resource is that it has to deserialize or serialize. It tells you, or tells the serializer where to get the ID or what the ID is, because maybe the model that comes back has article ID instead of just ID. So you could actually change the mapping of the fields here, so you don't have to expose basically your database column names. Obviously also how to get the attributes, and the thing I forgot is basically if there are relationships, it would tell the encoder how to fetch the data for the related objects. And that's the server side. Of course, there would have to be a schema for the person as well. But Ember Data, on the Ember Data side, you have a simple model specification, again, just the attributes, and the author is a relationship, and because we only have one, it belongs to. That's how a one-to-one or a one relationship is expressed. On the person, we have the same thing, first name, last name, and articles is a relationship that basically a person can have multiple articles, so that's how that relationship is expressed, and that's it. On the JavaScript side, this is all that's necessary to tell your client application how to talk to the server. This actually allows Ember to talk to the server with get, post, delete, and patch. That's the amount of configuration. That's it. And to me, that's huge. I mean, there's nothing else to be done. So then who's using this? We already heard Booking.com. The Hoodie team announced that they're using that for part of their API. Patreon is the donation service that lets you make repeating small donations. And then, of course, Ember Data. I think there's probably more, but these are the ones that I'm aware of. So if you want to get more information about the project, this is where you can find it at JSONAPI.org. Obviously, it has the entire specification, the 1.0 version of it. They are working on 1.1 at the moment. It also talks about, or gives you information about extensions. That's not something I mentioned yet. Extensions are basically extra things that they don't want to put in the standard, and they're working on some, though, that will be considered official extensions. For example, a bulk extension where you can send, instead of having to send a delete operation for each individual resource that you want to delete, you could bundle them up in one request. And I think you can actually even mix things. So you could say update this and delete this all in a single request. As I mentioned earlier, they make recommendations. So there's an entire section on recommendations. Then there's a ton of examples that you can view. And of course, there's the list of the implementations themselves. And one last thing I want to mention about this is the discussion forum they have there. It's basically just an online forum, but where you can go and ask for help, ask about JSON API. And in my experience, it's been absolutely amazing how friendly and respectful the people are there. And I think that's just worth mentioning because you don't get that everywhere. They will answer your questions without making fun of you, and really, really good answers. So very cool people, I just have to say that. So that sort of brings me to the end of my little introduction to JSON API. Hopefully you are interested in it. If you want to ask questions now, that's great. If you want to have other questions, I'll be here today and tomorrow. Or if you think of something next week, go ahead and send me an email or get me on Twitter. Thank you very much. Yeah. Yes, it does. It's yeah, the standard specifies to some degree how you should express pagination. Yes. Yeah. Yes. I don't think that they have Java yet on the client. No. There was another question there. How to document? No, it's not part of the spec, but you can definitely use things like Swagger or RAML or whatever other documentation libraries there are. It doesn't exclude that at all. Yes. Yeah. No, I am not actually. No. Any other questions? Yes. Yes. I don't know all the specifics, but one of the big differences is that basically the document nesting, that you have this single one level deep structure of all the resources, whereas HAL can be very, very, very nested. And I think also how relationships are expressed and links are expressed is slightly different. Yeah. Yes. Yeah, sorry. I'm sorry? Oh, like hypermedia stuff. It's not part of the specification itself, but there's nothing that basically says that you can't do that. Yes. So you could build in link systems that would tell you, basically let you make it self-discovering. Yes, like hypermedia. Anyone else? Yes. Yes, it does. I have personally done with Ember and WebSockets, basically just send the payload through the WebSocket, and then on the client you can listen for that. And if you send it as a JSON API compliant document, then you can just push it into the serializer without doing anything more. So in that sense, maybe it doesn't have to necessarily go over HTTP, but I don't know if that's a, yeah. I think generally, yes, it's HTTP for sure. Anyone else? All right, thank you.